Hi everyone, my name is Mustafa. Welcome to my channel. For today, we are concluding the Create and Manage Cloud Spanner Database quest, and we'll be evaluating our readiness of all the labs that we've done in this quest. Before we dive in, please make sure you are subscribed to my channel so that you don't miss upcoming videos that I'm going to be sharing related to database and data engineering on GCP. For today's tasks, it is a challenge lab and we'll be evaluating our understanding of the previous labs in this quest. As usual, we'll start our lab by clicking on Start Lab. After clicking on Start Lab, then we'll open the lab in an incognito window. Click on Next, copy our password there, paste the password in so you understand. So we are trying to sign in into our Google Cloud console. So and this is the dashboard of our console. Agree to the terms and service, then agree and continue. Here is our dashboard and this is our console. So the first thing we have to do in this lab is, these are some of the objectives that we have. We want to create a Cloud Spanner instance, create a Spanner database, create a table in your database, load simple data set into tables, load a complex data set, and add a new column for an existing table. So that's the major thing we'll be doing for this lab. So we've completed all these parts. So let's activate our Cloud Shell. To activate our Cloud Shell, click on this to activate your Cloud Shell. After activating your Cloud Shell, then we'll also authorize the Cloud Shell and see our active projects for this lab. So let's wait for it to provision our Cloud Shell machine. So after that, we can use the Qcloud hotlist. Let's authorize this. And just to see the active project account, you can use Qcloud config list project. So this is our active project for this lab. This is our accounts for this lab. So I think we are good to go. Let's keep going. So for task 1, we want to create a Cloud Spanner instance. And if you've followed us through each of the lab, we've shown how to create Cloud Spanner instance with the console. We've also showed how to create it using the CLI, that's the command line interface, using the Cloud Shell. We also showed how to create a Spanner instance using Terraform. So for today, I'm just going to be using this sample command. So I have a list of the command here that I'm just going to be editing the part that I'm going to edit among them. So for this one, this is the command and it's similar to what you can see here. This is the command here, similar to what you can see here. I just need to replace this with the name of the instance. So the name of the instance they gave me here is banking ops instance. And looking at this one, I already have banking ops instance here. For my region is US East 4. So for this lab, so I'll change this one to US East 4. Then the description can be banking instance. The number of nodes, they want us to use 1 node. That's fine. So 1 node here also. So just copy this command. Then let's go back to our Cloud Shell and paste this here. So you can see it's created our instance. So you can also use the console like I've explained. And if you want to see the instance that has been created, we can go to our Spanner. Under databases, we have Spanner. And click on Spanner. If you go up, this is the instance that we've just created. And you can see 1000 processing units, which is equals to 1 node. This is the region that we specified, US East 4. So this is it, it's empty, there's no table, there's no database currently in this instance. So let's also create a database. I think that should be the next task. So we can check our progress. This is fine. So let's create a Cloud Spanner database. and we want the name to be banking ops db. So when we move here also, this is the command Qwiklabs spanner database. This is the database name that we are creating, and we are creating it under the name of the instance that we used previously, banking ops instance. So you have to specify the instance that you want your database to be created, and that is why you cannot create a database on Cloud Spanner without having an instance, but you can create multiple databases in an instance. So let's also paste this in our Cloud Shell and run it. So it will create our database. You can see it's creating our database for us, and our database is done. If you refresh this part, you should also see the database now. So you can see the database banking ops db. So we are good to go. So, and this is just the command. This is the command I use. I just change this to the database name, and I change this to the instance name. So you can also validate your progress. So for task 3, we want to create tables in our database, and this is the sample. This is the format that we use to create table. So create table, then the name of the table, then this will be the columns that you want to be in that table. This will be a column 1, column 2, and this is the data type. This is also the data type, and this is the primary key. You specify the column that would represent the primary key here. So for portfolio, these are the columns that we want: portfolio ID, name, short name, and portfolio info. And we want an int 64, not null, for the portfolio ID, and the other should just be string marks. And the primary key is portfolio ID also. So I already have the command here. So you can see create table. This is portfolio. These are the columns: portfolio ID, name, short name, portfolio info. And we want our portfolio ID to be the primary key. So you can just copy this command. Make sure when you are copying it without white space. So let's just check this once again: ID, name, short name, portfolio info. So they correspond. So we can go to our database, click into our database. So when we click into our banking ops db, so you can see there's no table, but we want to create tables. So we can create tables with DDL statements. So just click on write DDL, and let's paste our command here. So let's see if there's no error here. You can click on submit, and when this code runs, it's going to create a table named portfolio for us. So you can see it's creating table portfolio, and it has done that. So the next thing we want to do is, let's create the next table that they asked us to do. So we also create table category, and these are the columns names in category, and this is the primary key ID. So let's go back to our code. For the category, this is the column name, category ID in 64. Then we have the category name, string marks, and the portfolio info, string marks, and this is the primary key. So you can just copy this command once again, then come to our DDL and write another DDL. Just got this. So let's paste the DDL once again. Let's confirm if it's correct, and click on submit. So it's updating our DDL. So we'll do the same thing for the other tables name that we have. So this is also created. Let's just double up. We have for products. This is the product. These are the column name for product. These are the column name for customers. So I have it here. Just copy this part. This is telling me to use string 25. Let's confirm here. Okay, this is also correct. So come to our DDL, write another DDL, paste this, then we'll click on submit. So DDLs are just data definition language that you can use to create tables. You can use to alter schemas of tables, etc. So let's write the final DDL statement for this, and that will be for customers. So come here also, we have our code here. You can copy this code for customers. Then come here and paste it once again. Make sure there's no extra white space. Cancel this. And let's click on submit. So here are all the tables that we have: portfolio, category, product, and customers. And each of them are empty. If you want to confirm if they are empty, let's just do a dry run on one of them. Let's do a dry run on customer. So select star from customer. Let's click on run. And you see that this query did not return any row, which shows that the table is empty. If I change this to category and do a run also, it will also be empty, as we don't have any data in those tables at the moment. So since that's the case, let's insert data into those tables. So going back to the tags, we have load simple data set into tables. So let's load some data set into each of our tables. And we've talked about different ways to load. You can load one by one. There is also a batch loading, and there's also loading in batch for large quantities with data flow. And you can refresh about that in the second video for this playlist, which is Cloud Spanner, loading data and performing backups. You would understand how to load data easily there. So these are the columns. These are the data that we want to load into the portfolio table. I already have a sample code here. So this is our portfolio table. We have the name. These are the column names there. We have the name, the short name, and the portfolio info. And this first part is representing the, so we under our values, we have different values that we want. So the portfolio ID, this is the portfolio ID. It's number one. We have our name also. We have the short name, which is this one, BNKG, and we have the portfolio info, which is all business banking. So you just copy all this command here. So there are different ways to write this code. You can load them one by one by saying insert info, then this one, then one of this one, then say insert info once again. But I'm just setting the column names and putting the values and separating them by parentheses and comma. So that's fine. To insert, you can insert from your editor. Just paste the command here, and the command should be valid. So when it's valid, you can run it. So when we run it, we would confirm if, so it's telling us that 3 rows have been inserted. To confirm that those 3 rows have been inserted, you can do a select star from portfolio, click on enter, and you can see these are the 3 columns that we inserted. So that's regarding that. We also have to insert some data into the category table, and these are the data that we want. So I have a sample code here also. So we are inserting the category ID, portfolio ID, and category name. So this one is representing the category ID. This second one is representing the portfolio ID, and the last one is representing the category name. So we can copy this. And if you also look at it here, so the arrangement that you set here, that's what will happen here. So if I place portfolio ID before category ID, it's going to take this one as the portfolio ID, and in this case it's wrong. Copy it here, go to our editor and paste this command, and it should also be a valid SQL. So it's a valid SQL, then we can click on run. So it has returned 4 rows. We can also confirm this. We can do select star from what's the name of the table that we just did, just to confirm the name of the table, category, and we'll run it and we'll see the data that have been inserted. So we have these 4 data here, and that's fine. So for the last table, which is product, these are the data we want to insert into our product table, and I have a sample code for it also, which is here. So under this product, we are filling the product ID. This is the product ID, the category ID, the portfolio ID. We have the product name, the product asset code, which is this one, and the product class, which is this. So if you remember that under this category, we actually add more columns. If you take a look at the command for the category, so we have category ID, portfolio ID, category name, and portfolio info. But when we are loading the data, we are only loading into 3 columns because they did not specify the data for other ones. But we can get that by using the join on other tables to get the. So we have category ID, portfolio ID, and category name, which is category ID, portfolio ID, and category name. So we can get the portfolio ID and portfolio info. We join with this product table based on the category ID. We should be able to get the portfolio ID. Under this product table, they specify the portfolio ID for us. Okay, so that's fine. Let's copy just the last command. That's just by the way. Come here, paste, insert data into our product table. So let's run this statement. And you can see this statement inserted 9 rows. So let's confirm once again. Select star from products. Then run your command. So you can see this is all the data that we inserted into this table, and we are good to go. So you can view our tags here. Let's check our progress. So our progress is complete, and the next thing we want to do is load complex data sets. So now we intend to load over 500 data, just 500 data into a table, into our customer table. And like you would imagine, you wouldn't want me to be doing that, loading that one by one, loading that bit by bit. So I'll be using data flow, and data flow is going to load everything in batch. It's going to just do a bulk run and load everything in batch at once. So this is the URL of this is the cloud storage bucket link to where my data set is, the data set I want to load. This is also the HTTP URL. So depending on the method you want to use, but I'm using data flow for these tags. So you can see it's telling us that we can choose to create simple insert statement, but that would not be economical. That would be very, very time consuming. So we wouldn't do it that way. So we are going to be using the data flow tags. And when we are doing the data flow tags, we have to specify some things that would specify along the way. So let's get started. To get started, the first thing we want to do is we have to create a cloud storage bucket, and we have to create an empty file in that bucket because we are going to write the data to those files at a point in time before it now get loaded to the spanner database. So looking at this command here, I also have a command here. So what this command is doing is that GSP381 make bucket. So this MB means make bucket, and this is the name of I'm specifying this name to be the name of our bucket. Don't forget that your bucket name has to be unique. I know that the project ID of this account is unique across all projects, is unique. So that is why I used my project ID as the name of my bucket. I know it to be unique. So then I'm doing a touch empty file. So I'm creating an empty file. Then I'm copying this empty file into this bucket, and this is the part of it. So GSP381, this is the name of our bucket. Inside the TMP folder is creating that empty file into that. So I can just copy all this command and run it in my Cloud Shell. So let's run those commands in my Cloud Shell. Then click on enter. So you can see it's creating our bucket after it's telling us that this name already exists. That is because I did not change the name of this project ID. So this project ID has been used to create a previous name before. So sorry for that. Let me use my own project ID, my current project ID. So this is my current project ID. So if you also just copy this code here without editing it, you would get the same error. So use my own project ID and also use my project ID here. Please make sure you change them. or you can use a unique name of your choice. So copy this, then cancel that. Let's paste it once again and enter. Can drag this up a little bit. So it's created the bucket. After creating the bucket, it also created the empty file, and then it copied the content of the empty file into our bucket path. So we have that on lock. So the next thing we are going to do is, for data flow, when you're using data flow, you have to configure the APIs for data flow. So I want to disable the data flow if it is enabled before. I want to first disable it, then enable the data flow API again, because I'm not sure if it's disabled or enabled before. You can just confirm that by maybe searching for the API name and see if the API is actually enabled. But to just be certain and to avoid error along the line, I would first disable it, then I'll enable it again. So this first command is first disabling it if it's actually enabled, then this second command is going to enable it for me. So I can just paste this also here in my Cloud Shell, and then enter. So you'd see it's the first operation is finished. And now we have our data flow service actually enabled. Okay, so that's fine. The next thing we can do is, let's just duplicate this tab and go into our data flow. So let's search for data flow here. Data flow will be under analytics. We'll keep going down. Yeah, so under analytics, we have our data flow here. Let's click into data flow. And we'll be using a job from template. So we have some predefined templates to move jobs around. So for this one, you can just you can name it any name of your choice. Let's say I want to use spanner job load, and my region, let's confirm my region. I think it should be US East 4 for this lab. So US East 4. So let's set my region US East 4. And the data flow template. The data flow template that I'll be using from cloud storage, text file on cloud storage to cloud spanner. And it will be under process. It should be under process data in bulk. This part that we are. So let's go down. So we have text file on cloud storage to cloud spanner. This is the one we are choosing because we are moving the file from cloud storage to cloud spanner. So let's click it here. We have some required parameters that we have to set. We have to set the spanner instance ID and the spanner database name. So all these are just the instance name, the database name, and we also have to set the manifest file that is going to tell data flow how to load this data into it, and would select a temporary location for our loading. So all these are just easy to get. So we can get our spanner instance ID by going back to the command that we have here, or we can just pick it from this first tags. This is our instance ID. Copy it here, paste it here. To get our database ID also, you can also pick it from the next tags, which is our database ID. Copy it here, then paste it here. Then to do the manifest file, have a template of the manifest file, but we have to edit this manifest file in our code editor, in your code editor here, before you now like upload this file into our cloud storage bucket. So this manifest file has to be on the cloud storage bucket also. So I can just duplicate this previous one so that I create, let me move it to the third part. Then I would go to my cloud storage bucket. So while on our cloud storage bucket, let's also check the bucket that we created previously. We remember that I used the project ID name, and this is the bucket that we created previously using the command line interface on our cloud shell. So when I click into this bucket name, we should see a TMP. I created a TMP folder and put that empty file into the TMP folder. So when we click under our TMP now, we have an empty file here. So let's we want to create our manifest file in this part and upload it here. So going back to the instruction that we have here, so we are unload a complex data set. So this is a sample of the manifest file that we are using. We'll set the table name, would set the name of where the data is currently. Then we'll also use our columns here. So to do that, I also have a sample code here that you can just build on. So copy this sample code here. Then you go to your VS Code. So let's go to my VS Code. Just click on VS Code here. Then a new file. So let me name it manifest.json. Yes. So let's create file, and I'll paste my code here. So the table I want to use is customer also. So if this if where the source changes, you can confirm that and replace it with the link that they give you in your lab. But let me confirm mine also. So this is still the source. I can just copy it and replace it there to be very much certain, but I think it's still the same thing. So change it, and my file is good to go. And these are the columns names. The first one is customer ID, the name, the location. So all these are already specified for us in the lab instruction, so you can see they're specified for us. And if you look at our customer table, these are the 3 columns that we have there. Let's just go back there under our customer table. So this is portfolio, category, products. Okay, we'll see that in the DDL. So these are our customer table, customer ID, name, and location. So we are good to go. So let's save this file. So after saving it, then we'll upload it to our cloud storage bucket. So let's go back to our cloud storage bucket so we can upload files. So you can see now it's uploading the manifest.json here. And when you click on this manifest.json, you should be able to see what it contains. So this is now the path to that manifest.json. This is the path, and this is the path that would now input in our data flow job for where the manifest.json file is. So when I copy this path, I can just go back to our data flow job and import this manifest file here. So I'm going to cancel out this first year sitting, and you should confirm that. And our temporary location, so we have our temp empty file already that we can just use here. So you can navigate to that. So this part, and just select it. So that's the temporary location for this lab, and we are good to go. The next thing we want to do is let's go over the optional parameters and see if we can choose some machine type. So I don't want it to use maybe the default machine type, so I can just come here and choose maybe a E2, and I think this should be fine. Can also, so we are using medium. Can decide to use this standard. Let's see if I'm able to use it, but I know that the medium should be fine. So let's click on run job. So you can see our job has started, and as you know, it takes a while. It takes between maybe like 10 to 12 minutes for the data job to get completed. So when the job has started running, and when it starts showing the graph, I'm going to fast forward it and see at the end. So I'm waiting for the graph to pull up. Here's our graph, and you'll be seeing that when it starts running, these stages are going to be changing. These stages are going to be changing. So this is still 0 of 99. So you can see that this part has started running and is now in 6 of 99. So I'll just fast forward it and see at the end. Yes, so this has actually succeeded. So it took less than the 12 minutes I even envisaged. It took a while for it to get started, but when it got started, it was quite fast. And you can see that it was just like quite very much easy. So while that is that, so data float is telling us that it has loaded our data into our cloud spanner, but are we going to just trust it without confirming? So let's confirm and actually see if our data is loaded. Remember that we specified the data contained 500 rows, so we are supposed to see 500 rows in our customer table. So to confirm that, we can just do a select. Let's count. What can we count? What do we have in our customer table that we can count on? So let me just go back to, okay, we can count on customer ID. So let's count customer ID. Let me call it count of customers. Then from our table name is customer. So let's run this guy. Let's see. So yeah, we have 500 rows, which is fine. So let's view some of the details here. Let's just view some of the details here. Let me see. Let me just say select star from customers. Let's see. So you can see which are the data that we have, and data are like quite much. So this is just 30 out of 500. So you can decide to view everything, but this shows that we've actually loaded our data into the cloud spanner table. So let's validate our tags and see if we are good to go. So good to go here. And the last task for today is to add a new column to an existing table. So that's we'll be using a DDL command for that also. And this is a template command. So Qwiklabs spanner database, then you pass the DDL tag here. So we are updating. After you have update, then you set the name of your database here. So this will be the name of your database. Then your instance, set the name of your instance here. Then the DDL flag, then your command is now alter table. So you're altering the table, the sample. So the sample will contain the table name, add column, then sample value. This will contain the column name that you're adding, and this will be the data type that you're adding. So here now we are asked to add marketing budget. So our sample will change to the name of the table, which is category, and our column name marketing budget will come under sample value in 64 in 64. So this is how you can just actually copy this command alone and run it as a DDL statement, but this command is just to run it in Cloud Shell. So just use the Cloud Shell method. I have the command here also. I can just copy it. Don't forget, this is our database name, our instance name, and this is the DDL command that we are running. So come here and I can go to my Cloud Shell here and paste this command. So enter. So let's wait for it. So it's updating the schema and doing everything. So it's done. Yeah, it tells us it's done, and we can confirm that. So we can just confirm that by doing a dry run on our category table. Yes, so select star from category. If we run like that. So you can see, when we loaded the data, we did not specify any data under portfolio info. So our portfolio info is still empty. And the new column that we created, marketing budget, is also empty. So which shows that we are good to go. And I think that's all for this lab. So let's confirm our progress. And our progress is also complete. So congratulations, everyone. you've completed create and manage cloud spanner database challenge lab. And in this lab, we created a spanner instance and database. We also created tables. We loaded data into tables. And we performed DDL operation on the tables. So, and if you followed us on this playlist, you should also have this lab create. You should also have this badge create and manage cloud spanner database. So thanks very much for staying true to the end of this lab. If you enjoyed this lab, make sure you like it. Share your comments in the comment section. Let me know your thoughts about this lab, and you can also suggest multiple labs that you want me to work on next. And don't forget to subscribe to my channel. Don't forget to like this video. Don't forget to share it to your loved ones so they can also learn from creating and manage cloud spanner database. Bye for now. See you in the next playlist.